Okay, so we've all heard the big story, right? Our Milky Way galaxy is on a collision course with Andromeda. It's always painted as this, inevitable cosmic smash-up.
Yeah, absolutely. That's the standard picture. Two giants heading straight for each other, merger guaranteed.
But is it really that certain? That's what we're digging into in this deep dive, looking at some really interesting new science. It uses the latest buzz from telescopes like Gaia and Hubble to rethink things.
Exactly. Our mission really is to see past those older, maybe simpler predictions and figure out what the most up-to-date observations and, frankly, more complex analyses are telling us about what's next for us and Andromeda.
Okay, so let's break that down. This idea of a definite collision, it came from earlier models, yeah? Simpler ones.
That's right. Often they basically treated the Milky Way and Andromeda like they were the only two important things interacting in the whole local group, kind of a two-body problem setup.
Right, like just calculating the paths of two main players.
Sometimes they might have thrown in M33, Andromeda's big companion galaxy, but still, the focus was often on finding the most likely outcome based on sort of average numbers for speed and direction.
Like trying to predict exactly where two billiard balls will go, but galaxies are. Well, they're way messier than billiard balls. They're huge, complex, and crucially, there are other galaxies around pulling on them.
And that's a key point. Plus, our ability to measure everything perfectly, it's just not there. There are always uncertainties, especially with something called proper motion, that tiny sideways drift across the sky over vast distances. Even Gaia and Hubble have limits.
So this new study we're looking at, it basically says, hang on, let's factor in more of the neighbors and really own up to these uncertainties in the measurements.
That's the heart of it, yes. Their main model, the one they call their fiducial model, it includes the Milky Way, Andromeda M31 and M33, and the Large Magellanic Cloud, the LMC, which is a pretty hefty satellite galaxy of ours.
And bringing M33 and the LMC into the calculation, that actually changes the prediction.
Oh, significantly. And what's really interesting is how they affect things differently. Adding M33, Andromeda's companion, that actually boosts the chance of a merger.
Okay, how so?
Well, it's gravitationally tied to Andromeda, and its presence adds just a little extra pull, sort of nudging Andromeda slightly more in our direction, statistically speaking, across the simulations.
Huh. Okay. And what about our own big neighbor, the Large Magellanic Cloud, the LMC?
The LMC is fascinating. It seems to do the opposite. Its gravity, as it orbits us, interacts with the Milky Way's halo, and it can create a kind of drag or recoil effect on the Milky Way itself. This effect tends to work against a direct head-on course with Andromeda.
So M33 is sort of helping the merger along while the LMC is maybe putting the brakes on or steering us slightly off course.
That's a reasonable simplification, yeah.
Yeah.
But the really crucial takeaway, after they ran millions of simulations exploring all these interactions and the full range of possible values for the uncertain measurements like the exact proper motions, the masses, even the distances, is that a merger is.
Yeah.
Well, it's far from guaranteed.
Right. So what is the number then? What's the probability now based on this more complex picture?
Okay, so using the latest data, incorporating these other major galaxies, and properly accounting for all those measurement uncertainties, the probability of the Milky Way and Andromeda merging within the next, say, 10 billion years is only around 50%.
50. So hang on. What we thought was practically a certainty is now looking more like a coin toss.
Based on this latest, very detailed analysis, yes. That earlier certainty came from data that wasn't quite as precise and models that didn't capture the full gravitational dance or properly weigh those unavoidable measurement uncertainties.
Wow. This deep dive really shows how science works, doesn't it? You get better instruments, better data, more computing power, and a picture that seemed settled can suddenly look very different.
It absolutely does. And it highlights just how challenging it is to make concrete predictions over cosmic timescales. Tiny uncertainties now can blow up into huge differences billions of years down the line. The precision needed for certainty about proper motions over millions of light years is just immense.
So wrapping up, the big takeaway seems to be that this epic collision we've all heard about, maybe not so inevitable. It's looking more like a 50-50 shot based on the latest evidence, mainly because predicting the exact paths and accounting for all the gravitational nudges, plus the errors in measuring things like sideways, motion, and mass, is incredibly tricky.
Precisely. The complexity of the local group environment and the inherent limits of our measurements mean the future isn't quite written in the stars yet.
It really makes you think, doesn't it? If predicting the future of something as massive and you think predictable as a galaxy is this uncertain, what does that suggest about our ability to predict anything, really, and just about the sheer dynamic, maybe even chaotic nature of the universe we're in. Something for you to ponder.